Okay, so first we're going to use synthetic division. And when we use synthetic division, I'm just looking for the numbers. I don't need x squared or anything like that. So I'm going to have 3, negative 5. We're missing an x term, so I'm going to put a 0 there, and negative 2. And I need to divide by the opposite number, which is 1. Okay, to start, I'm going to bring down my 3. I'm going to multiply to get 3, and then add to get negative 2. Multiply to get negative 2, add to get negative 2, add to get negative 2. Did I do something wrong here? Or is this right?
Right, that's right.
Okay. Some people I saw had zeros here. Should that be 0?
Why is there 0?
Here?
Yeah.
Because I'm missing an x term. See how I go x squared and there's no x? So I got to put a 0 in there. And this should be negative 4, not 0. Okay? And remember, this number represents our what?
Remainder.
That is our remainder. This is our constant. That's our x. And that's our x squared term. If there were more, then it would be x cubed and so on. So the answer, when you divide 3x cubed minus 5x squared minus 2, and you divide that by x minus 1, our answer is 3x squared. 3x squared minus 2x minus 2. And then my remainder is negative 4. So I'm going to put minus 4 over whatever we divided by, which was x minus 1. Questions there? Okay. Now the next problem says to determine whether the binomial is a factor of the polynomial function. So I'm asking, is x plus 4 a factor of that polynomial? What needs to be true if it truly is a factor? William? Need to have a remainder of 0. So what we're going to do is we're going to divide this polynomial by x plus 4. Am I missing any terms here?
No.
Yes. No. No, you're not.
I'm missing the constant at the end. So at the very, very end, I better have 0. Go ahead and do that one on your own, please. So again, we need to flip our sign, make it negative 4. We need to make sure we have a 0 at the end because we do not have a constant term. So when I synthetically divide, I'm going to bring down my 6, multiply to get negative 24, add to get negative 30. If I make a small mistake, let me know. Negative times a negative is a positive 120. Oh, what's this? Is this 36? 36 times negative 4 is going to be negative 144, and I will get a 0 there when I add, then multiply times a 0, add to get a 0. So this is in fact my remainder, and that is 0. Okay, so the question, hey, determine whether x plus 4 is a factor. Yeah. Is that yeah?
Yeah.
Yeah, it is.
So that's our answer.
Essentially, if it says determine, it's either a yes or a no question. What's our evidence? Well, that's our evidence. That supports our answer. I got one more. The next problem says, show that the binomial x plus 7 is a factor of the polynomial. Now remember, if it says show, what does that mean?
Show your work.
I said, hey, Cole, show me how to do a cartwheel.
Are you serious? We'll do it.
Would I call Cole up here in front of us if Cole couldn't do a cartwheel?
Yeah. Probably
Yeah.
can.
No, that'd be embarrassing to him. He could hurt himself. Okay, but if I knew Cole could do a cartwheel, I'd say, Cole, show us. Show us that it's a factor means it is going to be a factor. Okay, it is, and then from there we need to factor it completely. Okay, so go. So am I missing any zeros here?
Yes.
I am. Am I missing any terms? I am. I'm missing an x squared. So 1, 0, negative 37, 84. You do the opposite. So I'm showing, right now I'm thinking, hey, x plus 7 is a factor. I'm just showing it. So I'm going to bring down my 1, multiply to get negative 7, add to get negative 7, add to get 49, put my 49 on, multiply to get 49, add to get, what is that? 12. 12 times negative 7 is negative 84, and add to get 0. Okay? Now, it says factor completely. So remember, I'm left with, this is my remainder, this is my constant, x in x squared term. So I'm going to have x squared minus 7x plus 12. Okay? And I factored out already in x plus 7. Now, can I factor this guy? Factors of 12 that add up to negative 7. Is that negative 4 and negative 3? So I'm going to have x minus 4 and x minus 3. Any questions about anything that I've done up here? So before Christmas break, this is kind of where we left off. We worked on synthetic division, we worked on showing that things are factors, and factoring things completely. Now today, we're going to kind of go from where we left off. So, section 5. Everyone should have a notes. If you don't, let me know. It's titled Solving Polynomials. Now, one thing we need to understand here is that when I say solutions, hey, find the solutions, that's the same thing as finding the zeros. When I say, hey, find the zeros, that's the same thing if I were to say roots. I don't use roots a lot. Or if I say any one of those three things, it means x-intercepts. So essentially, we're just finding where the graph crosses the x-axis. Okay? Now, one thing I want us to understand, not sure how much we'll use it today, but we will in the future. If I had something like this, it's already factored, isn't it? So the zeros would be where? Remember, we need to do the opposite. So x is going to be 4 and x is going to equal 1. Okay? Yeah, that's not new. That's review. So if I were to graph it quick, the x-intercepts would occur at 1 and 4. So if I were to graph it, maybe it looks something like that. The x-intercepts occur at 1 and 4. Okay? Now, if I had something over here, aren't those the same thing? So x is going to equal what? 2 and 2, but it's the same thing. Okay? So essentially, we have what we call a repeated solution. Okay? It's the same thing twice. Now, what this means is that I know at 2, there's going to be an x-intercept. But if it's a repeated 0, then instead of crossing, don't draw this, but instead of crossing like that, it's going to bounce. It's going to come, hit the x-axis, and bounce back up. So it's never going to actually cross the x-axis, it's just going to touch it. Okay? Again, not sure if we'll come across that today, but we will here moving forward. All right, so example 1. Let's go back up there to our objectives. Our objectives is to find solutions of polynomial equations and zeros of polynomial functions. Basically, we're finding the zeros, we're finding the x-intercepts. Okay, well, so if I go down to example 2 here real quick, it says, hey, find all the zeros. It doesn't say show that this is a factor. It doesn't say, we're not given a factor. We're just saying, hey, find them. Okay? So in order to do that, we have to use something called the rational zero theorem. And it's up here in the box. So here it says, if a polynomial f of x has integer coefficients. Oh my goodness. What in the world is that? Integer coefficients. What's an integer? A positive or negative whole number. What's a coefficient?
Something that's like
It's in front of our variable. Okay, so a coefficient of 4x is 4. So we need integer, positive or negative whole number coefficients. We can't have 1/2 x. It throws this out. But so I'm just letting you know, we will always only have integer coefficients. Then every rational solution of this polynomial f of x is in this form of p over q. And p is the factors of the constant. Okay, p represents the factors of the constant, and q represents the factors of the leading coefficient. Okay, I'll go down to example 2 here and I'll step you through and I think it'll make more sense. So here we go. We've got a polynomial, x cubed minus 8x squared plus 11x plus 20, and we're supposed to find where that thing crosses the x-axis. Okay? So we don't know exactly. Okay? But what we can do by doing p over q is find a list of possible answers. Okay? Find a list of possible answers. So what are p would be factors of our constant, right? So factors of 20 are 1 and 20. I'll just do 1, 2, 4, 5, 10, and 20. Those are factors of 20. Okay? And factors of our leading coefficient. What's our leading coefficient here? There's a 1 there, isn't there? Okay? So now what we need to do is take all of our p values and place them all over all of our q values. Okay? So our possible zeros, and we need to put plus or minus in front of them. So it'd be plus or minus 1 over 1. What's 1 over 1? 1. So plus 1 or negative 1, that's a possibility. Okay? Then we need to do plus or minus 2 over 1. What's 2 over 1? 2. Plus or minus 4 over 1, which is 4. Plus or minus 5. Plus or minus 10. Plus or minus 20. Tristan. We are only looking at p and q. We're only looking at the factors of our constant, factors of our leading coefficient. Okay? How many numbers do I have here? I have 12. Okay? I have 12 because it's plus or minus. I've got 12 possibilities of zeros. Okay? Now, everyone needs a graphing calculator. I want you to graph that in our graphing calculator. And I don't think mine works. I never got mine fixed. God. It just... I don't know about you guys. I don't find this very funny. Yeah, I can't do it on here. I'm sorry. But I want you to graph it.
Sounds pretty good.
What am I doing?
So we are graphing this guy. Plug that in. And hit graph. And what we're going to do is we're going to use our graphing calculator to figure out, okay, where are they? Which ones of these possible 12 are we really looking at? Because there's 12 possibilities, but there's not going to be 12 zeros. So when you graph it again, we're looking, okay, where does it cross the x-axis? So once you've graphed it, if you're looking for x, it's right there. Once you've graphed it, I'd like to see it. Yeah. So you need minus 8x squared.
Yep.
You too. You need minus 8x squared. I like yours.
That is weird.
I could be wrong a little bit, but I think it looks something like that. Really brief. We're just looking, hey, where does it cross the x-axis? What numbers does it cross the x-axis? Tyler, can you tell me one?
It was like 4.04.
I don't know if I like that one.
-1, -4, and 5.
So let's just pick one.
Negative
-1. Would you guys look at the graph and would you guys agree?
Yeah.
If we want to verify, can't we pull up the table? Yeah, absolutely we can pull up the table. Now here's what we're doing. Our goal is to find all of them. Okay, now I think we can use the graphing calculator to figure that out. We can look and see, hey, they're here. But that won't work all the time. Okay? So what we need to do is use synthetic division. So I'm going to synthetically divide 1, -8, 11, and 20. Now I'm going to stop you. You said -1. Is -1 on our list?
Yes.
It is. Okay? So at this point, usually people are like, wait a minute, Mr. Cole. You're telling me I could just do the graphing calculator and not do the list of P and Q? And the answer is, yeah, you could. But on a test, I'm going to ask you, do you understand this concept? Okay, why do I do that? Well, Mr. Jeffer does. You're going to learn the same stuff in pre-calc next year if you take that. Mr. Jeffer teaches it the same way. Okay, I want to make sure I'm modeling what he's doing so when you get there, you're not confused. You've seen this before. So he'll do it this exact same way. On a test, I want you to write all the possibilities out. Here's all the possibilities. Okay, so now we go to the graph and we said -1 it looks like. So I'm going to plug in a -1 there. And we're going to synthetically divide, because if it truly is, if -1 is truly a 0, what should we get as our remainder? 0. So bring down my 1, multiply to get -1, add to get -9, multiply to get 9, add to get 20, multiply to get -20, and add to get 0. Bingo, bango. -1 is a 0. Okay? Now, I have x plus 1 as a factor. Remember that. If -1 is a 0, then x plus 1 is a factor. And now I'm left with x. Remember, this is my remainder, this is my constant, this is my x, and this is my x squared. I'm going to have 1x squared minus 9x plus 20. Can that factor? Factors of 20 that add to -9, -4, and -5, right? So I'm going to have x plus 1, x minus 4, and x minus 5. Those are all my factors. Now, remember, from my factors, I can find the zeros. So my final answer would be x equals -1, x equals 4, and x equals 5. Those are my 3 answers. Now, could we have gotten these from our graphing calculator way a long time ago? We could have, okay? But here's the issue. In some other problems that we're going to be doing here, maybe not today, but moving forward, you can't get them all from the graphing calculator. So how do you get them all? You get them all by doing this process. So we start easy. Hey, learn how to get them all very easily, and then we'll work into some more difficult ones. Ralphie, question?
If you would have used a different number, would you have done the same answer?
Yes, okay, that's a great point. Let's say we used 4 instead of -1 to start. You're still going to get the same answer. Maybe the process along the way is a little bit different, but in the end, you're going to get the same answer.
Like, so if you just use, like, instead of +1, you use, or no, like you said, you use -1, you use 4?
Yes, yes, yep. But if you would have used 3, well, you wouldn't have gotten 0 here. That would have told you it's not a factor. But if we would have used 4 or 5, it would have worked. Okay, example 3. I don't want to do that problem, so I'm gonna, let's get a different one for us. Let's do this one. So you can erase that, do whatever you want. I'm gonna 3. Sorry, 3x cubed plus x squared minus 38x plus 24. So it says, hey, find all the zeros. Well, we're going to do P and Q. Factors of 24 are 1, 2, 3, 4, 6, 8, 12, 24. Guys, it should be like 1 and 24, 2 and 12, 3 and 8, 4 and 6. Okay? Now, Q. What are factors of 3? Because again, Q is our leading coefficient. Factors of 3 are 1 and 3. Okay, so this is a little different. Now we just don't have 1 as our leading coefficient. So for P over Q, all of our possibilities, it's going to be all of these numbers over 1, and then all of these numbers over 3. So we're going to have some more possibilities here. So I'm going to start by just 1 over all these numbers over 1, which essentially is just all of these numbers. Would you agree?
Why is there 1?
Say it again.
Why is there 1 and 3?
Because we're looking for factors of 3. Well, factors of 3 are 1 and 3. Does that make sense?
Yeah.
So in the other problem above, or the problem previous, it was only a 1. So we just had a 1 there.
So like if we did that, like there's a 10 right there, we have to write 1, 2, 5.
10. If we did this problem, it would have to include 1, 2, 5, and 10. Yes. Okay? So I'm going to do plus or minus 1, plus or minus 2, plus or minus 3. Again, I'm just doing all of these numbers over 1. Plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 24. Now we have to do those numbers over 3. Okay, so 1 over 3 is 1/3. Plus or minus 2 over 3 is 2/3. Plus or minus 3 over 3 is 1. Didn't we already have that?
Yep.
Yeah, so let's not write it again because we already have 1 here. Okay, plus or minus 4/3, 4 over 3. Plus or minus 6 over 3, what's that? 2. Again, we already have 2. Let's not write that again. Plus or minus 8/3. Plus or minus 12 over 3 is 4. We already have that. And 24 divided by 3 is 24 divided by 3, 8. 8. And we already have that. Okay, again, what are these? These are all of our possibilities of our zeros. And we should notice here, now we've got some fractions. They may not be perfect whole numbers. Okay, now go ahead and graph it. I can't stress enough, make sure and double check that you typed it in correctly into our calculator. may I?
Yeah, of course.
I think it should look something like this. Okay? Now, what we're looking for are whole numbers, because if we could avoid fractions at all costs, we probably should. So are there any whole number ones that are for sure? Yeah. -4 and +3. What's the other one? Does that look like a tweener, like in between?
Yeah.
So we're saying, I'm sorry, -4 and +3, but then Hannah's saying that other one might be a fraction, because it's possible that we can have a fraction in here. So let's avoid that one until the very end. So the other one you said was, let's try 3, okay? So I'm going to synthetically divide by 3. Could I use -4?
Yep. Yeah.
Liam and Hannah,
Yes.
you guys are going to start with -4,
Okay.
okay? And the rest of us are going to start with 3 and see if we get the same answer, okay?
Okay. I see you.
So, bring down my 3, multiply to get 9, add to get 10. Multiply to get 30, add to get -8, multiply to get -24, and I get 0 here. So that means x minus 3, the opposite of that's a factor, and now I'm left with 3x squared plus 10x minus 8. Now, again, our goal is to find all the zeros. We're going to have to marf that. So when I marf it, 3 times -8 is -24. Factors of -24 that add up to 10. 6 and 4? Factors of -24 that add up to 10. 6 and -6 and -4? That doesn't work, does it? Because -6 and -4 is positive 20.
12 and 2.
Oh, 12 and 2.
Yeah.
How about positive 12 and -2?
Yeah.
Okay, so I'm going to rewrite it, 3x squared. Oh, let's see here, plus 12x minus 2x minus 8. And again, now we're factoring by grouping. Let's factor out a 3x. So I'm left with x plus 4. Let's factor out a -2, so I'm x plus 4. And so my two factors are 3x minus 2 and x plus 4. And then don't forget to bring this one down, x minus 3. So in the end, my zeros are x equals positive 3, x equals -4, and I believe from the beginning Hannah had said that. But then this other one we didn't quite know. Well, what's this one going to be? Positive, opposite of that number, divided by that number, 2/3. So these are our zeros. Liam and Hannah,
What?
did you get these 3 answers?
We're almost there.
Almost there.
Yeah, we're almost.
Did you get hung up
Say we
somewhere?
got them.
Did you get hung up somewhere?
We're still working on it.
Okay. I'm guessing you got maybe hung up here, factor by grouping.
Exactly.
No, we definitely got that.
You did.
Yes.
Yeah.
So Hannah got it. Liam, you were just a spectator.
I was helping.
Okay. Moral support. Okay. Moral support. Right. Let's stop there for today.
Yeah.